Okay, in the last video, we learned about the basics behind reading a periodic table, and what I want to do now in this second video on the periodic table is correlate the basic physical properties of the elements with the periodic table. Now, a very quick review. We've learned that the periodic table in the last video, that the periodic table is set up by increasing atomic number, and we see that there are two fundamental numbering systems in the table. We have group numbers, which are a reference to the vertical column of elements, and we have period number, which is a reference to the horizontal row that goes across the table left to right. And we see when we follow a period number from left to right that the elements are increasing by atomic number. So the table is set up to represent the elements in order of atomic number, moving left to right across the period. Now, in terms of talking about the physical properties of the elements, we see that the vast majority of elements on the periodic table are comprised of metals. All right, metals are hard, they're dense, they're malleable, and they're ductile. That means that they can be stretched into wires, and they can be and they're flexible. They can be bent. They conduct electricity and they conduct heat. There's two special cases of metals on the left side of the table that I want to take a moment and talk about. The first are the metals that occur in group 1A. That would be specifically lithium, sodium, potassium, rubidium, and cesium. These are called the alkali metals. They're called alkali because it turns out that group 1A elements are the most reactive of all the metals. So when they're combined with water, when you combine a group 1A element with water, there is a vigorous reaction that produces hydroxide, which is a strong base. Solutions that result from the reaction of group 1A metal with water produce basic solutions which will turn red litmus blue. So these are called the alkali metals because during reactions with water they make basic solutions that cause litmus paper to turn from red to blue. By the same token, the elements that fall in group 2A, the metals that are in group 2A, while they're less reactive they're less reactive metals by comparison to group 1A, they still are highly reactive compared to the other metals. And similarly, in a reaction with water, group 2 metals will cause the formation of solutions that are basic and will turn red litmus blue. So these particular metals are called the alkaline earth metals. So group 2A is called the alkaline earth metals, and group 1A is called alkali metals. And again, they're given these names because of their high level of reactivity, but mainly the fact that they produce basic solutions when they react with water. The other metals are less reactive, generally not reacting with water alone. Some of the transition metals, these would be the metals that make up the center of the periodic table, will react in solutions that in the presence of acid. For example, zinc and aluminum fall into this category. In the presence of hydrochloric acid, zinc and aluminum will react strongly with water to produce hydrogen gas. On the right side of the table, we have two more important classes of elements. The far right side is encompassed by nonmetals. And these predominantly have the opposite kinds of physical properties by comparison to the metals. They're far less dense. We see that there are several elements here that are normally gases at room temperature. For example, nitrogen, oxygen, fluorine, and chlorine, and then the noble gases, which take up their position in group 8A, are all gases at room temperature. In general, the nonmetals do not conduct electricity, and they also conduct heat to a far lesser degree than metals do. We also see that nonmetals are unique in that at least one of them, bromine, is a liquid at room temperature, and iodine, in an unusual sense by comparison to the other nonmetals, is actually a solid. This group in the middle that fall to either side of the black zigzagging line are called the metalloids because these particular elements, the ones in general that I have boxed in red, have characteristics that are in between a metal and a nonmetal. So some of them conduct electricity, For example, some of them can form solids in the presence of oxygen that have moderate conducting properties and so on. So the main thing about a metalloid is just understanding that it has combined properties of both a metal and a nonmetal. One last thing to mention about the metals: mercury is unusual in this particular collection because it's also a liquid at room temperature. So in the periodic table we've got two liquids, bromine and mercury.